Hi, fifth grade. Ms. Bishop here, and I'm going to go over the assignments we had this week and also review some directions for the investigating factors and the array slides that we had. So the way to look at these assignments is to open Google Classroom. And I'm actually going to move myself over here so I'm out of the way, and I'm going to open my Google Classroom just like you guys do on a daily, and we're going to click on classwork. So make sure you click on my class and you're going to click on classwork, and we're going to look at this investigating factors assignment because the IXL is pretty explanatory. You kind of know what to do with that. So in the investigating factors assignment, we were investigating how to find the factors of any number. Okay, any number, and we were using arrays to find those factors. So it's a strategy for finding factors. So the first document I'm going to open is the Do I See Patterns with Fractions document, and this is a chart that we filled out with our factors. The other document that I had you guys open was the Making Arrays document, because this is the place where we practice making arrays for our numbers to be able to determine those factors. So if we look at this slide, we see that arrays look like this and not arrays look like this. So if you notice, arrays are a single square or rectangle. They have equal rows and they have equal columns. And that's how you know you have an array. Arrays do not have items missing in the rectangle or square, and they are not and they are always in some sort of shape. So they are not random like these stars right here. So they're always in an organized rectangle or square. And the way that they can help us determine the factors of any number is because they show us what we can multiply to get our number. So for example, if we had the number 8, I'm just going to pull 8 of these suns out, and I'm going to make an array to figure out its factors. So I have 4, 5, 6, 7, and 8. Okay, so I have 8 suns there, and I put those 8 suns in one row. So this is the multiplication fact 1 times 8, because I have one row of 8. So one row of 8 equals 1 times 8, which equals 8. So that's one way I can find the factors of 8. So 1 and 8 would be factors of 8. 8 is also divisible by 2. Which means I can take these 8 suns and I can make 2 equal rows of 4. So this also shows us the factors of 8, because we all know when we multiply 2 times 4, we get 8. So 2 rows of 4 equals 2 times 4, and that equals 8. Okay? We can also make, we can also make 2 in 4 rows. So we can have 4 rows of 2, and we can have 4 times 2. But those two arrays are the same. They're just kind of rotated. Okay? So we were able to find all our factors. What we can't do with the number 8 is we can't put it in rows of 3, because 8 is not divisible by 3. So you can really play around with these counters or suns that we would normally have and help figure out what the arrays are. So that's one example we did in class. Another example we did in class was the number 13. Okay, and you'll notice something very different happens with the number 13. So of course, every number can be put in a single row, because every number has factors of 1 in itself. Okay, so 13, you can make 1 times 13, because every number has those factors. Okay? So easy. 13 has 1 times 13. But guess what? You cannot put the number 13 into equal rows of 2 or in 2 equal rows, because the number 13 is not even, therefore it's not divisible by 2. So the number 13 cannot be put into 2 equal rows. It has a leftover. The number 13 also can't be put into 3 equal rows, because it does have something left over. Okay? It also can't be put into 4 equal rows. So 13 is one of those numbers that only has factors of 1 in itself. Okay? And we can use these arrays to help us figure out the factors of any number just by looking at, well, what kind of numbers is that number divisible by? Okay, so we did that. So after we did those two examples, then I gave you guys this workboard to be able to do that with all the other numbers I wanted you to find factors for. And that's what this other document was for. So what we were doing is we were filling out the factors for all of these numbers to 25. All right, because we're going to see some patterns with factors and we want to point them out. So the number 1 only has one factor. You can only do 1 times 1. So the factor is 1. And because you can only do 1 times 1, that means that it's only going to have one array because there's only one factor pair, 1 and 1. Okay, but we don't need to write 1 twice because 1 is 1. All right, and because 1 does not have a factor of 2, that means it's not divisible by 2. So that means 1 is even. All right, the number 2, however, has factors of 1 and 2. And the reason that 2 has factors of 1 and 2 because you can only do 1 times 2 or 2 times 1. Those two arrays make the same array. So that would be one array as well. Oh, I'm sorry. 1 has to be odd. Whoops. I just saw that mistake. Okay, so 2 is 1 times 2. Okay, so it makes one array, but because 2 is divisible by 2, because it has a factor of 2 and it's a multiple of 2, that means that 2 is even. Okay, so remember 1 is odd. Sorry about that. All right, now if we get to 3, 3 also only has 2 factors. You can only multiply 1 times 3 or 3 times 1, which means that it has one factor pair, so that means 3 can also only make one array. Now if you look at 3, 3 is an odd number because it's not divisible by 2, it doesn't have a factor of 2, and it's not a multiple of 2. All right, so it gets a little different when we get to 4 because 4's factors are 1, 2, and 4. And the reason 4 has more than 2 factors is because you can do 1 times 4, that's one factor pair, but you can also do 2 times 2. That's a second factor pair, which means 4 will have 2 arrays, not one array. 4 is also divisible by 2. It has a factor of 2, and it's a multiple of 2. So 4 is going to be even. Now 5 is the same as 1 and 2 and 1 and 3. It's 2 and 3. It only has 2 factors, 1 and 5. So that means it's only going to have one array, and it doesn't have a factor of 2, so therefore it is an odd number. All right, when you get to 6, I'm just going to scoot this down a little bit. 6 has more than 1 in itself. You can do 1 times 6, but you can also do 2 times 3. So one factor pair is 1 times 6. That's one array. Another factor pair is 2 times 3. That's a second array. So 6 is divisible by 2. It has a factor of 2, and it's a multiple of 2. That's why it's even. And then, of course, the pattern continues with 7 with just two factors. That's going to be one array. That makes 7 odd. And then we'll do 8. So 8 has factor of 2, 4, and 8. So I can do 1 times 8. That's one array. And I can do 2 times 4. That's another array. So 2 factor pairs. That means we're going to have 2 arrays, which means we're going to have an even number. Okay? So what you needed to do is you needed to fill out all the factors to 25 because you're going to see some really cool patterns with those factors. And we have a lot to discuss about these numbers because there's so many cool things you can learn with understanding factors. And we're going to use factors all year, even when we get to fractions. Okay? So the discussion questions that I needed you to do, and we're going to do these in class on Friday, is we're going to talk about all of these questions. What do you notice about factors? Make a list of patterns you see. How are even and odd factors different? How are prime and composite numbers different? What do you think would happen if you continued to find the patterns past the number 25? So we really want to think about all the cool things we can learn from understanding and investigating and really describing these factors. So the one thing I haven't talked about is prime or composite. Now, prime and composite numbers are determined based on the factors of a number. So if we look at our factors over here, you'll notice that the number 2 has 2 factors, and you're going to notice that there are several numbers that only have 2 factors. So the number 2 only has a factor of 1 in itself. The number 3 only has a factor of 1 in itself. The number 5 only has a factor of 1 in itself. And the number 7 only has a factor of 1 in itself. Now, this happens throughout our table, okay? And you're going to notice that numbers either have 2 factors or they have more than 2 factors, except the number 1. But we'll get there in just a second, okay? All right, so to be prime or composite depends on how many factors you have. So prime numbers have exactly 2 factors, okay, 2 factors. And those 2 factors have to be 1 in itself. So if you look at our chart, you'll notice that the number 2, the number 3, the number 5, and the number 7 all have factors of 1 in itself. Numbers that have a factor of 1 in itself are called prime. So 2 is a prime number, 3 is a prime number, 5 is a prime number, and 7 is a prime number. And that's because they all have factors of 1 in itself, and they have exactly 2 factors. All right, so these other numbers, 4 and 6 and 8 and a bunch of other numbers on our chart, are going to have more than 2 factors. In fact, they have 3 or more, or they have more than 2 factors. So numbers that have more than 2 factors or have 3 or more factors are called composite. And that's simply because they have more factors than prime numbers. So therefore, 4, 6, and 8 are composite. Okay? All right, now let's look at the number 1. To be a prime number, you have to have exactly 2 factors, 1 in itself. To be in a composite number, you have to have more than 3 factors. If we look at the number 1, we notice that the number 1 only has 1 factor. So because the number 1 only has 1 factor, it doesn't meet the criteria for prime, and it doesn't meet the criteria for composite. So the number 1 is neither prime or composite because it doesn't meet the criteria for prime. It doesn't have exactly 2 factors, 1 in itself. It also doesn't meet the criteria for composite because it has only 1 factor, and composite numbers need to have more than 2 factors. So that's why 1 is neither. So the thing that we're going to do on Friday is really talk about, well, what is the difference between prime and composite numbers, so that you guys should be able to answer question number 4 after tomorrow's lesson. Okay? Now, what everyone is going to have to do once we investigate that and we learn about prime and composite numbers is all of these discussion questions down here are going to need to be filled out. You're going to have to tell me your thinking, explain your thinking, because it's not just as important to do the math. It's more important to explain your thinking and tell me what you know with words, because that's where true understanding comes from. So this is going to need to be completed by Friday. Once we have, this chart is almost filled out, by the way. We only had to do this column right here. And the other thing I want you guys to do is on the slides, there are 6, 7, and 8, 7, 8, and 9 slides. What you're going to do is make an array for the number 11 here, and then you're going to make arrays for the number 12 here. So those are the 2 things you're going to do with the slide. And of course, I just don't want to know the math. I also want to know what you're thinking, okay? So there are 2 questions that you're going to answer with this. How do arrays help us understand the multiplication facts, and what is an array in your own words? And you're going to type your answer here and make sure you use complete sentences to answer the questions above and use 12 or 11 as your evidence. So make sure you're including those 2 numbers when you type up your writing, when you type up your response. Okay, so just as a reminder, we're learning about factors and how those factors can help us determine prime and composite numbers, because we're always going to be using factors in math this year. All right, so you're going to do a great job. If you have any questions, remember you can always contact me, email, private messages on Google, Bloom's messages, whatever you need to help you understand. All right, I'll see you guys tomorrow. Have a great, great night.